All right, CR26, you guys, is absolute value, and we're going to talk about its numeric definition. We'll get into the algebraic definition of absolute value later in the course, but the absolute value of a number is its distance from zero. So, for example, the absolute value of -4 is it's a distance of 4 units from zero, right? So the absolute value will always be positive because it's a distance. For this one, we have the absolute value of -5/8, of course, would just be its distance from zero is just 5/8, right? If you're finding the absolute value and you got a mess in there, you go ahead and clean up the mess with the order of operations. So 4 times -5 minus 20, 7 minus 20, -13, and the absolute value of -13 is just positive 13. You guys go ahead and try that next one right there. Just punch it into the chat. Should get 35 over 2. Now the algebraic definition of absolute value. So you'll also see it written like this: the absolute value of x is just x as long as x is greater than or equal to 0, or it's the opposite of x if x is less than 0. Right? So for example, if you're taking the absolute value of 3, we know the absolute value of 3 is, we know it's just itself because 3 is greater than or equal to 0, right? So the absolute value of 3 is just 3. Now, if I was taking the absolute value of -5, now -5 is less than 0, so it's, the algebraic definition says take the opposite of that x value. Take the opposite of the -5. So the absolute value of -5 is just 5 per the algebraic definition. Okay, so we're going to use that definition to solve absolute value equations. And so let's do this first one here. Again, keep in mind that the absolute value of x is x when x is greater than or equal to 0. So the opposite of x if x is less than 0, right? So right here, I make sure that my absolute value is isolated. It already is. I have just the absolute value of x is 21. So I have two cases. I have case 1. The absolute value of x can just be x. So I just drop the absolute value. And then case 2. And for that case 1, I'm using the absolute value of x is just x. Case 2. The absolute value of x is the opposite of x. And now I put a negative in front of my absolute value equals 21. I'm going to solve each of those separately. This one's already solved for. This one I got to go ahead and divide by -1. So 21 or -21 is my solution set. Either number could satisfy the original, right? Because we know if we plug in 21 there, absolute value of 21 is 21. If we throw in -21, the absolute value of -21 is also 21. All right, let's apply it for this one. So we know the absolute value of x is x if x is greater than or equal to 0, or the opposite of x if x is less than 0. Well, now I have absolute value of x minus 10. So following the same definition, the absolute value of x minus 10 would be, case 1 would be drop the absolute value x minus 10 as long as x minus 10 is greater than or equal to 0. In other words, as long as x is greater than or equal to 10. And then the second scenario would be, it would be the opposite of whatever's in there if that is less than 0. In other words, if x is less than 10. So that's our two cases. Okay, so we'll do our case 1, drop it. Case 2, put a negative in front of the absolute value. And then we'll solve each of these. separately. Let's solve case 1. So 13 is one proposed solution. Now case 2. Divide by -1. So 7. And notice if I check both of those, if I check the first one, 13 minus 10, and we're like, yeah, that works, right? Absolute value of 3 equals 3. Let's check case 2, which was x equals 7. So I plug 7 in. I'm like, oh, there it is. Absolute value -3 is 3. So yeah, both of those are solutions. So my solution set is 7 and 13 is my solution set for that one. So the absolute value is all by itself. I run the two cases. Case 1, I drop the absolute value. Case 2, put a negative in front. And we go ahead and solve each of these. Divide by 2. Distribute the negative here. Subtract 5. Divide by -2. So this one, our answer is -2 and 7. You guys go ahead and try this one. Notice it's already isolated, so go ahead and try that. Should get -5 and 2 on that, guys, when you work that out. Now notice this one's a little bit different. My y absolute value is not completely isolated. So before I can run my two cases, what I'm going to do is I'm going to get rid of the 6 first. So then I have the absolute value of y plus 12 equals 6. Now I can run the two cases, okay? So make sure again that you isolate the absolute value before you run the two cases. So you got -18 and -6. Okay. This one here, instead of having a number in front of the absolute value, it has that +2 that I got to get rid of before I can run the two cases. So I'm going to go ahead and subtract 2 on both sides. So now I have the absolute value of 11x minus 7 equals 2. Now I can run my two cases. Case 1, drop it. Case 2, put a negative in front. Okay. So 5/11 and 9/11. Yes, similar.
I have a quick question.
Yes. All right, let's get rid of that 15 first, isolate it, and then we'll run the two cases. So here's what we have. The absolute value of x plus 10 equals -3. Case 1. Case 2. Add 10. Divide by -1. So it looks like we got -13 and -7 on that is our proposed solutions. Now, in all reality, let me pause it right here and have you think about this. What is wrong with this solution? Does anyone see anything wrong with this before I even check my answers? So I kind of wanted to point out here that if I'd have run through everything and got to the end, if I hadn't checked this, like if I throw in negative 13 into the original, I have the absolute value of negative 3 plus 15 equals 12. 3 plus 15 does not equal 12. That doesn't work. That does not work. And if you throw in the negative 7, you'll see that that doesn't work either. So where could you actually stop on this? You know, I was kind of robotic and I was running through it and not even thinking about it, right? But once I've isolated it, I have absolute value of x plus 10 equals negative 3. The absolute value of a number cannot be negative, as Megan pointed out, right? So right there, you should just say there's no solution. But if you didn't catch it and you ran through it, make sure you check it. And neither of those solutions will work for you. All right, let's run through this one. Let's go ahead and get rid of the minus 6. So we have the absolute value of x minus 5 equals 0. Can the absolute value of something be 0? Sure. Let's see what our case 1 and case 2 throw out as solutions. Drop the original. Subtract 5 both sides. Notice it gives me the same answer. So there's just one solution on that, 5. And if you throw it into the original, you can see that it does satisfy the original. All right, why don't you guys go ahead and try this one right here. Go ahead and pause it right there. You guys kind of check your work there. Thank you, Bella. Appreciate it. Now this next situation has two absolute values, right? Now remember, we have the absolute value of 11x minus 9 is 11x minus 9, blah, 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 or it's the opposite, right? But the absolute value of 9x plus 4 also has its two cases, 9x plus 4, opposite of 9x plus 4. All right, so what I'm going to do first is, my first case is I'm going to drop the absolute value for the 11x minus 9, and then I'm going to consider the 9x plus 4 to be its first case. All right, so there's the first one. And then the case 2 would be the opposite of 11x minus 9 equals the 9x plus 4. And actually what that does is it takes care of every scenario. So you could also do 11x minus 9 if you left that alone and then you did the case 1 with 9x plus 4. Well, these are the same. And then you leave the 11x minus 9 and you do the case 2 with the 9x plus 4. Well, the only difference is the negative is on that side, but these are also the same. So I don't need to do case 3 or case 4, if you will. I just got to do the first two. Okay, so if you have two absolute values, go ahead and drop it. I like to drop it on the right hand side, and then I run my two cases with my left hand side. Okay, and then you'll get both solutions on that. So let's go ahead and subtract 9x here. Get all your x's on the left. Add 9. So I got 13 over 2. And let's see, over here I got subtract 9, divide by negative 20, so that's 1/4. So it looks like I have 1/4 and 13 halves. 1/4 and 13 halves. All right, why don't you guys try that one? Go ahead and check yourself. Thanks you guys for working that. Let's now move into, you'll see how this definition is very nice when we're solving it with inequalities now. So with our inequalities, it's the same thing. You isolate the absolute value, and then you just run the case 1 and the case 2. So the absolute value is already isolated, so I just drop the absolute value. And case 2, I put a negative in front. Okay, so let's finish this out. So x is greater than 13. the only thing you got to remember is when you're working with inequalities, anytime I divide by a negative, here it is, right? I divide by a negative. Don't forget, you gotta switch that thing, right? You gotta switch the sense of the inequality, okay? And then the other thing you want to remember with inequalities is if you have an absolute value and it's a greater than scenario, so let me go up here. If you have a greater than or equal, that'll be an or inequality. Whereas if you're less than, the absolute value is less than, that'll be an and situation. So we're an or because we had a greater than. So this will be an or scenario. So here's how we write our answer. We'll say x is less than -9 or x is greater than 13. And we could graph both of those if we wanted to. Here's our -9. I'm strictly less than. And then I'm up here at 13 and I'm greater than. So I'm less than -9 or greater than 13. And there's our graph of our solution. Here's another one, but we don't have it isolated. Yeah, so what you want to do is add the one first before you think about it. So we've got the absolute value of 3x minus 4 is greater than or equal to 8. Again, it's greater than or equal to, so this will be an or situation when we run the two cases. So case 1, drop it. Or and let's go ahead and solve these. Divide by 3, which is positive, so the sense of the inequality stays the same. I'm going to subtract 4 on both sides. Divide by -3. Whoops, somehow I lost my greater than or equal to. Now I divide by a negative. Don't forget, that's going to switch that thing. So we're greater than or equal to 4, or less than or equal to -4 thirds. So I'm going to write it less than or equal to -4 thirds, or greater than or equal to 4. Here's -4 thirds, less than or equal to. So -4 thirds about right there. That's my -4 thirds. Greater than or equal to 4. You know, I should have done interval notation as well. So let's go ahead and write our interval notation. We're coming from -infinity up to -4 thirds with a bracket. Or means union, and then I keep going with 4 on. So there it is in all my notations there. Let's do this one up here in interval notation. It's coming from -infinity up to -9. Does not include -9. Union, or, that means or union. And then it goes from 13 on. Okay, so there's our interval notation for that one as well. All right, this one we got 5x plus 10 all over 7. It is isolated, so we can go ahead and run our two cases. But notice this is a less than or equal to. This is a less than or equal to, so this will be an and. This will be an and inequality. So case 1, let's drop it. And this time, meaning they both have to be true. And then let's put a negative in front of this one. And let's go ahead and solve both of these. So and multiply this side by 7, this side by 7. 5x plus 10. That's a positive number, so it still says less than or equal to. Let me subtract 10. Let me divide by a positive 5. So I'm less than or equal to 5, and I'm going to get rid of my 7 over here first as well. I'm going to multiply this side by 7, this side by 7. And then I'm going to distribute this. Negative 5x minus 10 less than or equal to 35. Add 10 to both sides. Divide by a negative 5. Well, that's going to switch our sense of the inequality. So that'll change that one. So I'm less than or equal to 5 and greater than or equal to negative 9. Let's put it on a graph here. Here's my 5. Here's my negative 9. I'm less than or equal to 5, and I'm greater than or equal to negative 9, and that's and, so it's only in between those two. So the actual solution sets from negative 9 up to 5, including the negative 9, including the 5. So we write that as a bracket, negative 9 up to 5, or we can say it this way where we put them together. All right, there's our solution on that one. All right. Let me have you guys try this next one. 2x plus 6. Notice here we have the absolute value is already isolated, and the absolute value has a less than on it. So since it's a less than, this is going to be an and situation. So go ahead and run our two cases. Make sure you got an and between them. Drop the first. Put a negative in front of the second. And make sure you know this is and. Both have to be true. All right, let's get rid of the 8 on this side. So times 8 times 8. So we have 2x plus 6 less than 24. I'm going to subtract 24. Divide by 2, that's a positive 2, so it stays the same. Over here, I'm going to multiply this side by 8, this side by 8. That's a positive 8, so it's not going to change the sense of the inequality. I'm going to add 6 to both sides. Divide by negative 2. Now when I divide by a negative, I better switch that. And both those got to be true. So I got to be less than 9. Here's my 9. I got to be less than 9. That's open. And greater than negative 5. Both have to be true. So my solution is between those. So from negative 5 up to 9. There's my solution set from negative 5 up to 9. Less than 9, greater than negative 5. Guys, I'm sorry. This just got pointed out. That's not a negative 5. That's a negative 15. I'm sorry. 15. There we go. 15. Sorry about that. 30 divided by 2 is not negative 5. Negative 15. Thank you. All right. Last one. We got absolute value of x minus 6 less than negative 12. Now think about this. Could we have an absolute value that's less than a negative number? Is that possible? Definitely not, right? Therefore, this inequality has no solutions, right? That's the no solution or empty set. All right, I think that'll get you kind of going on CR26. Thanks for watching.